equations. I'm going to maybe not go into such detail as maybe sometimes I would, but I'll briefly explain that the basic idea of the equations of circles come from the Pythagorean theorem, and that if I take the center of a circle and any point on that circle, I can draw the radius. I can draw the radius and then draw a horizontal distance and a vertical distance, and that this would be a difference in x, and this would be a difference in y, and this would be the radius. And so that it basically just, if I take x2 here minus x1, that's the difference in that horizontal distance, and that would be the difference in y. So if I took some y value minus some other y value, that I can then just use the Pythagorean theorem and square them. So the general form is x squared minus, x sub 2 minus x sub 1, the difference in the x's squared, plus the difference in the y's squared is equal to the radius, which is the hypotenuse of that triangle, squared. And that can determine any point along that circle. And so circle with center 0, 0 and radius of 8 would be x squared plus y squared equals 8 squared, or you could write it as x squared plus y squared equals 64. Just take the 8 squared and write it as 64. And again, that comes back from the idea that if this is my generalized form, x minus h squared plus y minus k squared equals the radius squared, that the center of the circle is at h comma k. The radius is whatever it is. And so if I took x minus 0 and squared it, plus y minus 0, squared it, and took the radius, which in this case is 8, and squared it, well, x minus 0 is still just x. X minus 0 is just x squared, then y minus 0, again, just y squared. And then you've got your 8 squared. And so pretty straightforward. Or if you have a circle with a center at negative 7, 5, that'd be x plus 7 squared plus y minus 5 squared is equal to 25, or 5 squared. And either way would be fine. So notice that this negative here, when you take x minus negative 7, it becomes x plus 7. And that 5 that's positive just came out here as x minus 5. So it kind of has that counterintuitive feel to it. All right, this next one, write the equations for circles with the following graphs. Here I see that the center of the circle is at the origin. So it's very much like the top one, number 1 in the merging question. I see that the radius oops, my pen's not writing. There we go. I see that the radius is 3. And so this is x squared plus y squared equals 3 squared, or 9. This one also has a radius of 3. But the center of this circle is at 4, 4, 3. This is 4 over an x and up 3. So its center is 4, 3. And so its equation would be x minus 4 squared plus y minus 3 squared is equal to 9, or 3 squared. And that's that one. On this one, it says to graph the circle. So first thing I want to do, hey, what's the center? The center of this circle would be at -5. Again, kind of counterintuitive. Comma 2. Also somewhat counterintuitive. And its radius, keep in mind that r squared, which is in this position, is equal to 4. So I have to take the square root of both sides. R then equals 2. So my radius is 2, and that's my center. So I go over here to -5, 2, -5, and up 2. That's the center. And the radius is 2. So I go over in each of kind of the cardinal directions, go east 2, and north 2, and west 2, and south 2. And then I can just draw quarter circles, and it has that radius of 2. It doesn't have to be perfect, but you gotta try to make it as best you can. And that's what that circle would look like. Now for the mastery, complete the square for the following circle and write it in its graphing form. Here we got to complete the square, so I'm going to take the first term, x squared. I'm going to write it with that plus 6x. I'm just putting it in somewhat standard form. I'm going to leave a space to complete the square for the x. And then I'm going to go over here plus y squared and minus 2y. And leave a space to complete the square for the y. And then on the other side, I've got -9. So I'm going to put plus blank for my x plus blank for my y. And then you'll recall with 6x, if I took that and just kind of put it in the box, I got x squared, and half of 6x would be 3x here, also 3x. That would give me x here and x here. X times plus 3 would give me the 3x. Down here, the same, plus 3, which means that this number here that I would need to complete the square, this kind of corresponds to this. And so I can see that 3 times 3 is 9, so this is plus 9. Here, this is plus 9, and I'm going to put 9 over here to keep the equation balanced. And so then over here, along that same train of thought, with y squared, half of -2y would be -1y, or just minus y, -1y. And then this would be y times y would give me the y squared. Y times -1 would give me the -1y, and y over here times -1 would give me that other. And a -1 times a -1, let's kind of color code this as well. -1 times a -1 would be a +1. And so this is +1, and over here also +1. I'm just doing the same thing to both sides. So there's my 9 added to both sides, and there's my 1 added to both sides. Because you got to keep your equation balanced, right? This is the middle of my equation. So I added 9 here, I had to add 9 here. I add 1 there, I have to add 1 there. All right, and so now I can factor it. This is x plus 3 squared, coming from these come basically from this right here, x plus 3 times x plus 3. So that's just x plus 3 squared. And then over here, this is plus y minus 1 squared. Same thing applies. This y minus 1 squared comes from y minus 1 times y minus 1. And then on the other side, this is just equal to -9 plus 9 would cancel each other out. You're just going to be left with 1. And so this is it. This is the equation of your circle in graphing form. I would be able to say that the center of that circle would be at -3, 1, and its radius would be at 1, because the square root of 1 is still 1. So there you have it. Practice, practice, practice. You got this.